I'd like to explain some of the different parts of the SPDM robot that we're going to be assembling. There's several different components. I'd like to break those down if I get the first graphic. This is the ORU tool change-out mechanism, or OTCM. This is basically the business end of the robot. It provides the capability to grapple onto structure or onto on-orbit spares or failed components, drive bolts out to remove and replace them. It's about the size of a fire hydrant, weighs in at about 115 pounds. This is then connected onto the end of the arm on the SPDM. Next graphic. This arm provides the fine dexterity with 7 joints on each arm. There's 2 arms total. This allows the robot to really maneuver into hard-to-reach places and be able to access any component that may need maintenance. This arm weighs in at about 662 pounds. This will become a key point later on. During some of our EVAs, the crew will have to maneuver the OTCM and the arm connected as a unit, which is about 775 pounds, which is really no small feat for an EVA crew member outside. Next slide. This is the SPDM body. It's really the backbone of the robot, and it provides the structure to mount the arms to, as well as some other interfaces for connecting different outfitting items that I'll get into next. Next slide. The ORU tool platform, or OTP, this is really a structural post which provides a place to temporarily stow spares during the maintenance process. Next slide. This is a graphic of the THA, or tool holder assembly. This is Dexter's tool belt. It has a number of different sockets and extenders which allow it to have the most robust capability to maximize its effectiveness at a wide range of maintenance activities. Next slide. Camera light pan tilt assembly. This is really the eyes of the robot. Allows the crew inside or ground operators to be able to see what the robot is doing and illuminate the work site. Next slide. Getting right into EVA 1, this will be performed by veteran spacewalker Rick Linehan with first-time spacewalker Garrett Reisman. Some of the objectives of this EVA will be to go straight out of the airlock and work on our mission's highest priority goal of preparing the Japanese logistics module for installation onto Node 2. Once that's complete, the crew will head up to the Space Lab pallet, which will have been pre-located up on the truss, and the crew will remove 2 OTCMs from their launch position and install them onto the end of the arms. Let's roll the first video, please. EVA 1 begins with our highest priority task. As I said, the crew will come out of the airlock, translate down the length of the structure to the aft part of the payload bay. There they'll find the Japanese logistics module. On this module there is what's called a passive common berthing mechanism. This is the structural interface between it and the Node 2. There's 8 covers which protect this surface before it is installed and prevent any debris from getting on that surface, so that we can maintain a good pressure integrity and a solid leak check when the modules are brought together. To remove these covers, Rick Linehan is going to translate down to the bottom of the module, remove each of these covers individually, and hand them up to Garrett Reisman, who will be positioned on top of the module with a bag for stowing them. You'll notice in this graphic there aren't a lot of handrails for Rick to hold on to down in this area, so that's definitely going to be a challenge for us. He basically has to use fingertip pressure onto the berthing mechanism itself to try to hold still. Once those covers are removed and the bag is locked up, the crew will translate down along the end of the Japanese module, where Garrett Reisman will perform the next task to prepare it for unberth. There are 2 heater cables which are installed to provide thermal protection while in the payload bay. He removes those connectors and stows them on a bracket on the side of the orbiter sill. From there, the crew is going to head up to the Space Lab pallet to work on the OTCM. Meanwhile, the Japanese logistics module will await its unberth for installation at the end of the EVA. The first work at the Space Lab pallet is going to be configuring some tools to assist in the assembly. There's some foot restraints which are relocated and installed onto the pallet. Rick Linehan will install one of these foot restraints into the space station arm and ingress it. At that point, he'll ride the arm over to the position of one of the OTCMs for its removal. Meanwhile, Garrett Reisman will be free-floating around the pallet. He has some electrical connectors which provide keep-alive power and thermal protection for the arm. So he'll be removing those connectors and stowing them onto a bracket. Rick Linehan also has an electrical connector he has to remove from the OTCM. This was providing thermal heater power during the period while it's stowed on station. Once that bracket is stowed, there's 2 clamps which he releases, and that allows the OTCM to be removed from its launch position on the pallet. He will then carry that OTCM, translating in the space station arm, to meet up with Garrett Reisman, where it will be installed onto the end of the first SPDM arm. Installing the OTCM consists of securing 4 mechanical fasteners, and there's 2 electrical connections which provide power and data between the OTCM and the rest of the body. From this point, basically the exact same thing happens on the opposite side of the carrier. There's a second OTCM which is going to be removed and installed onto its arm. One slight difference in how we perform this operation is dictated by the need to get the Japanese module out of the payload bay. We can't have both space shuttle and space station robotic arms working at the same time, so we have a very invested interest in stopping operations with a space station arm. Rick Linehan will get out of the space station arm and allow it to move to a clearance position, and then he and Garrett Reisman will work together to finish up the OTCM installation free float. At this time, the space shuttle crew will be taking the Japanese logistics module out of the payload bay and installing onto its home on Node 2. That wraps up EVA 1. It's going to be a long day for the crew there, with a lot of coordination between both robotic arms and the crew inside in the ground and the flight controllers on the ground. Coming into EVA 2, can I get the next slide? This will be performed again by Rick Linehan and first-time spacewalker Mike Foreman. The main objectives of this spacewalk are going to be removing the arms and OTCM combinations which were put together on EVA 1, moving them from their launch position and installing them onto the SPDM body. Can I get the video for EVA 2? Starting off the EVA 2, the crew will come out of the airlock and go straight to work on the Space Lab pallet. From here, the crew will have to remove a number of keep alive thermal connectors, and we'll start to work removing thermal blankets which cover the 7 joints on each of the arms. Access to these thermal covers is much easier while the arms are stowed in the pallet. It gets much more complex once it's installed, so we're going to try to utilize our time as best possible to get these off at this point. There's some clamps which have to be removed to free the arms, and again, the wrists and shoulders each have thermal keep alive umbilical connectors as well. Once those are released, Rick Linehan is going to be setting up an APFR foot restraint into the space station arm, where he'll ingress, and they will get to work on removing the first arm out of the pallet. In order to install the arms onto the body of the SPDM, the body has to be rotated up about 60 degrees. That can't happen with the arms in their launch position because there's a clearance interference issue. So the crew removes them and positions them onto a temporary stowage bracket on the Space Lab pallet, as shown here. Mike Foreman will assist with the securing of the fasteners which connect the arm to the pallet. At this point, Rick Linehan will move over and release 4 out of the 5 body restraint bolts which secure the body of the SPDM to the pallet, leaving 1 in place. And then they'll work together to begin removal of the second arm. The technique for removal of the second arm is slightly different in how we do it. Rather than stowing the arm on a temporary stowage bracket, we're going to put Mike Foreman in a foot restraint on the sill of the pallet, and Rick Linehan will remove the arm from its launch position, install some handling